Alright, so I discovered this question about simultaneous equations that I never got around to. It must have uploaded recently. So on the PowerPoint we went through what was the boat question and how was y found. So this one here, 3 hours for a boat to travel up 27 kilometres upstream, travelling downstream, travelled 30 kilometres in 2 hours. And remember I said it's probably easiest if you draw a little picture to help you out while you're doing this. So let's see if I can get that diagram happening. And it doesn't need to be particularly complicated. So the stream I'm going to have running that way. So that's the direction of the current. So when your little boat is traveling upstream against the current. So we're not going to row this time. I think we had a rowboat last time, didn't we? Doesn't really matter. You can find it on the other page. Oh, I think I drew it on the whiteboard. That's why. So there's my little rowboat, my power boat. And it's going to travel upstream this way. So the boat speed, the actual speed that we end up going, we went 27 kilometres in 3 hours. So that's an effective speed of 9 kilometres per hour. Now what's that 9 kilometres per hour made up of? Well, it's made up of the boat speed. I'm going to let B be the boat speed. But I've got to subtract the speed of the current. So even though the boat might say it's going at 20, if the current's pushing back the other way at 17, my effective speed would only be 3 kilometres per hour. Same sort of thing. So the boat's going in this direction, the current's against it, so it's B minus C. Going the other way, we've got 30 kilometres in 2 hours, which of course is 15 kilometres per hour. And that's made up of the boat speed plus the current. So when it's coming back the other way, so we've turned our boat around. Beautiful little boat there. There's my outboard motor. And under the water level there somewhere is the propeller. So we've got our boat coming back with the current. So it's got the boat speed plus the current together is 15 kilometres per hour. That's where the two equations came from. Add them together for elimination. You've got 2x equals 24. Divide by 2. X is 12. The question, where does the y come from? Well, once I know that x was 12, I just substitute it into either of the original equations, and you should be able to see that y would equal 3 to make them true. So, I hope that helps. All right, see you in the next question.